In this video, I'm going to be doing integration of trigonometric functions, but only where it involves fractions. All right, so this is somewhat of a fairly advanced concept. Now, the first one, I'll be doing two questions. So obviously, I'm doing this by example. The first question should be fairly straightforward because I'm just going to be using straightforward substitution. Now, for the second question, if you already don't know the double angle formulas, it's probably a time to revise it. I'll go through it, right? But like it's beneficial if you know them already. Okay, let's get started. The first one. Okay, so whenever you see just a single sine or a single cos at the top, things are going to be easy. So what you're going to do is whatever's at the other side. So in fact, whatever is not the single thing on its own, you're going to substitute that as u. So in this case, u is going to be equal to cos x. All right. If I had sine over there, I would have had to change it to cos by using the fact that sine squared plus cos squared is equal to 1. Right. But anyway, that's a bit of a. I'm getting sidetracked here. Okay, let's get back to the main question. So with this thing, as soon as I say u, I need to find what du dx is. So du is equal to minus sine x dx. And guess what? I have a sine x over here. This thing pretty much disappears. So this integral sine x on cos squared x dx is equivalent to saying the sine x dx term disappears, right? So this term disappears and ends up becoming minus du, and at the bottom the cos x is going to become your u squared. Okay, so now it's just a matter of simple using usual rules of integration. This is integration of minus u to the minus 2 du. Use your usual integration rules and you will end up with minus u to the minus 1 all over minus 1. So basically the minus 1 and this minus will cancel out. Okay, now remember, we're dealing with the integration in terms of x. A lot of people forget to put it back into what it was supposed to be. So in the end, you need to end up saying this is the same as 1 on cos x, and don't forget the plus constant. Okay, now let's get to the hard question. Question 2, where I need to be integrating 1 on 1 minus cos x dx. Okay, so for this question, we're going to be using this thing called a t substitution. All right, so t substitution, t formula, whatever you want to call it. But essentially, what we're going to say is t is equal to tan x on 2. Okay, let's see how this is going to play out. The first thing I need to do is to find what cos x is in terms of t. All right, so in order to do that, I'm going to draw a little triangle. Okay, so that's my triangle. Now what I'm saying is this angle here is x on 2. Tan x on 2 is equal to t. Right, so if you read it the other way around, tan x on 2 is equal to t. So what you can write this as t on 1, right? So opposite on adjacent, right? If that's the case, the hypotenuse is going to be t squared plus 1. Okay, so from this equality over here, what I can do is I can find out what cos x on 2 is. So cos x on 2 using this triangle is going to be, it's adjacent on hypotenuse, so in this case it's going to be 1 on t squared plus 1. And in the same way, we're not going to need this for this question, but I'm just going to write it down anyway. Sine x on 2 is equal to t on square root of t squared plus 1. Okay, so now remember, we're actually dealing with cos x, not cos x on 2. So this is where the double angle formulas come into play. So what I can, if you remember, your cos 2x is equal to 2 cos squared x minus 1. There are other variants, right? But for this question, I'm actually just concerned about this variant. If that's the case, in the same argument, I can say cos x is equal to 2 cos squared x on 2 minus 1. Right? So this is really what we need. So now I have cos of x on 2, which I can borrow from this guy over here, and just substitute into the formula. So essentially, I will end up with, so moving this up, so I'm looking at this thing, it will be 2 times, well, 1 on t squared plus 1 minus 1. Okay, making this one single fraction, so this 1 over here can be written as 1 plus t squared and 1 plus t squared, right? So simplifying this entire, these two fractions, I will end up with 1 minus t squared on 1 plus t squared. Okay, so we're almost done. Okay, so I can now write cos x in terms of t, but what really makes this useful is the dx term. Okay, so I need to find what dx is in terms of dt. So I'm going to be rewriting this thing one more time. So I have t is equal to tan x on 2 dt dx is equal to, so I usually write the dx on the other side because it makes things easier. In this case, remember tan differentiation is sec squared, right? So it's sec squared x on 2 times obviously a half, because I need to differentiate even what's inside the bracket if you must think of it thanks to chain rule, right? So it's going to be times a half dx. Okay, now sec squared, so remember how I said sine squared plus cos squared is equal to 1, right? If I divide everything by c squared, right, so over here I will get sec squared, over here is 1, this thing over here is 1, and this thing over here is tan, right? So essentially this thing over here is saying dt is equal to half tan squared x on 2 plus 1 dx. The last line, this t, the tan squared is actually t, right? So I will have half t squared plus 1 dx. So what is dx? So this thing can be rewritten as dx is equal to 2 dt on t squared plus 1. Okay, all right. So now we need, now we have everything that we need to solve this question. All right. So we have what cos x is, we have what dx is. Now I can just, it's just a simple matter of plugging in everything to the final thing. So I'll rewrite the question one last time before I jump into formula. So dx is finally going to be equal to the integral of 1 on 1 minus, so remember cos x, if I go up, it's going to be equal to 1 minus t squared on 1 plus t squared, and the dx is equal to 2 dt on t squared plus 1. Right, we'll eventually be able to cross off this thing with this t squared plus 1, but let's simplify that before we do anything. So I'm going to make this bit one single fraction right at the bottom. So it's going to be 1 on 1 plus t squared minus, in brackets, 1 minus t squared, right? All over 1 plus t squared and times 2 dt and t squared plus 1. Okay, so this guy will cancel out with this thing, right? Oh, I forgot the integral sign. Okay, so finally we end up with the integral of 2 dt, but I'll take the 2 outside, and all I have at the bottom, so when I simplify this bit out, I will end up having 2t squared. Is it 2t squared? Yes, the 1 and that 1 cancel out, and then it'll be 2t squared. In fact, like, so the 2's cancel out as well. So the final answer to this thing is, so this is t to the minus 2, it'll be minus t to the minus 1. And of course, don't forget to sub the x back in, right? So so this will end up being equal to minus 1 on tan x on 2 plus c. Okay, so that's it. If you have any questions, let me know. But I hope you enjoyed it. Thank you.